In today's lesson, we are going to talk about combination of transformations. The first thing you have to remember is that the transformation order is very important. You can have reflection on the x and y axis. You can have stretch or compression along x or y axis. You can translation along y-axis by moving the graph of the base function up or down, and you can have translation along the x-axis by moving the graph right and left. Now, what you have to remember is that the reflection and stretch and compression has to be done first, and then you can go ahead and do the translation. And the translations, they can be done either on the x-axis first or on the y-axis. In general, the equation which contains all the possible transformations is given by y is equal to a f of b x minus h plus k, where a represents the stretch or compression or reflection along the y-axis, b the reflection, compression, and stretch along the x-axis, h translation or movement of the graph along the x-axis, and k the translation or movement of the graph along the y-axis. Now, if a is less than 0, we are going to reflect the graph, the base function, about the x-axis. If absolute value of a, which is the number of a without the sign, is greater than 1, we are going to stretch along the y-axis. And if the absolute value of a is between 1 and 0, we are going to compress the graph along the y-axis. By what factors? By absolute value of a. For b, if b is less than 0, we are going to reflect the graph of the base function about the y-axis now. If absolute value of b, again, meaning the number here without the sign, is between 1 and 0, instead of compression that we did for the y-axis, we are going to stretch about the x-axis. And if absolute value of b is greater than 1, we are going to compress about the x-axis. But by what factor? Now this is the confusing part. The factor now, it becomes 1 over absolute value of b. And the constant h. If you look at the equation already is in the form of x minus h. If h is positive or greater than 0, we are going to translate or move the graph to the right by h units, and if h is negative, we are going to move it left along x-axis by h unit. K is the translation about the y-axis. If k is greater than 0, then we are going to move the graph up along the y-axis by k units, and if k is negative, then we are going to move the graph k units down. So these are all the factors or parameters which they affect the transformation of a function. Now we are going to solve a couple of questions here. In the first example, we have the function f of x is equal to x squared. The transform function has the form 1 over 2 f of 4 times x minus 3 minus 2. We are supposed to write the corresponding equation and sketch its graph and also describe the transformation here. If we look at the transform function, we can see that a is equal to 1 over 2, b is equal to 4, k is equal to 3. Remember, the formula is already negative, so h is 3, that's a mistake, sorry, and k is equal to negative 2. This means that if we start with the graph of the base function f of x is equal to x squared, we have to compress it by a factor of 1 over 2, because a is 1 over 2, which is between 0 and 1. And since b is equal to 4, this means because it's greater than 1, I have to compress it along the x-axis by a factor of 1 over 4. Remember, 1 over b, so 1 over 4. And then I'm going to translate it or move it to the right by 3 units and move it down along the y-axis by 2 units. So these are the transformation, the order of transformation that I have to do. Now, let's try to find the corresponding equation. We know that g of x is equal to half f of 4 times x minus 3. So this means replace x in f of x by this expression. So I'm going to have 4 times x minus 3 squared and then minus 2. This is 1 over 2. 4 times x minus 3 squared is going to give me 16 times x minus 3 squared minus 2, which is 16 over 2 gives me 8 times x minus 3 squared. X minus 3 squared gives me x squared plus 9 minus 6x minus 2. This is equal to 8x squared plus 72 minus 48x minus 2, which is 8x squared minus 48x plus 70. Now, this is the corresponding equation. But before I go into sketching the graph, remember this equation that we got here. Let's simplify it by writing as 8 times x minus 3 squared minus 2. This is our g of x. We know that the base function for a quadratic is x squared. So our base function is f of x is equal to x squared. Now if we compare this one to this, we can see that our a is 8, our b is equal to 1, our h is 3, and our k is negative 2. This means that the same graph that we had here looks like has a different transformation, but they produce exactly the same transform function when plotted. Meaning in this case, we are going to stretch the base function, which is y equal x squared, by 8 units along y-axis. Then we are going to move it right by 3 units. Then we are going to move it down by 2 units. And this is going to produce exactly the same graph. Although they look different transformation, but the end product is going to be exactly the same. Now to graph the two functions f of x and g of x, we already know how the base function looks like, x and y. If x, I'm trying to plot this one, if x is 0, then f of x is 0. If x is 1, f of x is 1, which is this point. If x is negative 1 squared is going to give me 1. So my base function looks something like this one. Now, for the transform function, I'm going to use this version of the function because from here I can easily find what is the vertex. The vertex, as you remember, is going to be the point 3 and negative 2. So x3 and y negative 2. So my vertex is going to be here. Now I'm going to use the mapping rule. Since we know what is A, B, H, and K, we can write easily the mapping rule is x comma y gives us 1 over B. B is equal to 4. So it becomes 1 over 4x. And then H is 3, so plus 3, comma, and K, A is 1 over 2, so it's 1 over 2y minus 2. Now I can use a couple of points from the original one and find the corresponding transform points. For instance, give you one example. We know that the origin is the vertex on the old one, so if I put 0, 0 in this mapping notation, I'm going to get the corresponding point to be 1 over 4 times 0, which is 0 plus 3 is 3. 1 over 2 times 0 is going to give me 0, minus 2 is minus 2. So we get the vertex is going to be transformed to this point, which is correct. Now let's pick another point, let's say 1 and 1. So we say 1 and 1 becomes 1 over 4 times 1 is 1 over 4 plus 3, comma, 1 over 2 times 1 is 1 over 2 minus 2. Now, 3 plus 1 over 4 is going to give me 3.25. And 1 over 2.5 minus 2 is going to give me minus 1.5. So this means that this point is going to change to 3.25. So 1, 2, 3, 3.25 and minus 1.5, which is going to be a point something like this one. And I'm going to do the same thing for this point, which is going to be negative 1 and 1. It's going to become 1 over 4 times negative 1 is negative 1 over 4 plus 3, and 1 over 2 times 1 is going to give me 1 over 2 minus 2. Now 3 minus 1 over 4 is going to give me 2.75, and 1 over 2 minus 2 is going to give me negative 1.5. Now if x is 2.75 somewhere around here, y is negative 1.5, which is here. So I'm going to get a graph which looks like this one. So this is the graph of the transform function. The next question is f of x is square root of x, and g of x is negative 2 f of 3x plus 15 plus 4. First of all, if you remember the general form for the transform function is f of a times f of b times x minus h plus k. But this form has 3x plus 15, so we have to make sure the coefficient of x is 1. So really I can write g of x is negative 2 f of square bracket. We factor 3 out, we get x plus 5 plus 4. Now if you look at this general form, you can see that a is negative 2, b is 3, h is negative 5, and k is 4. So this means that if I start with the base function, which is square root of x, and then first I reflected about the x-axis because of negative 2 here, then I stretch it along the y-axis because of 2, which is greater than 1. Then I'm going to compress it along the x-axis by a factor of 1 over 3. Then I'm going to move it left along the x-axis by 5 units, and then go up 4 units along the y-axis, and I'm going to get the graph of the transform function. Now to get the equation of the transform function, I'm going to replace x in f of x with 3x plus 15. So I'm going to get g of x is minus 2 square root of, instead of x, I'm going to write 3x plus 15 and then plus 4. So this is going to be my second equation. Now I have to go and plot the graph, but before I do that, I'm going to find the mapping notation. Remember that the mapping notation becomes x comma y goes to 1 over b. We found that b is 3, so it's 1 over 3x plus h, negative 5, and a, which is negative 2y, ay, plus k, plus 4. So this is my mapping notation. Now, to plot the graph, we know that for the main function, first of all, the domain has to be x greater than 0 for f of x, because under the square root can be negative. So if x is 0, y is 0. If x is 1, y is 1. If x is 4, y is 2. So plotting this one, 0, 0 is here, 1, 1, 1, 1 is going to be here, and 4 and 2, so 3 and 4 and 2 is going to be here. So this is going to give us f of x. Now to graph the second function, which is g of x, I'm going to use the mapping notation, and I'm going to see what the new points are going to be. When x is 0, I'm going to use this notation now. If x is 0, 1 over 3 times 0 is going to give me 0 minus 5. When x is 1, 1 over 3 minus 5. When x is 4, it's going to be 4 over 3 minus 5. Now I'm going to put y's in this equation. When y is 0, it gives me 4. When y is 1, it's going to give me negative 2 plus 4 is 2. When y is 2, negative 4 plus 4 is 0. Now I'm going to plot these values on the same graph. Okay, when x is negative 5, y is 4. When x is negative 5, so it's going to be 1, 2, 3, 4, 5. Y is 4. 1, 2, 3, 4. So it's going to be a point over there. when x is 1 over 3 minus 5. 1 over 3 minus 5 is going to give us about minus 4.7. So when x is minus 4.7, somewhere around here, y is 2. So it's going to be a point like this one. And when x is 4 over 3 minus 5, which is negative 3.7, y is 0. So when x is 1 to negative 3.7, y is 0. So we are going to have a graph like this one. And we can also find the y-intercept easily by setting x equal to 0. If we set x equal to 0, then g of 0 becomes negative 2 square root of 3 times 0 is 0, 15 plus 4, which is going to be equal to minus 3.7. So it's going to be somewhere around here. In this example, we have a race between two people. One is Eve, the other one is Byron. Eve is driving a car which is faster than the one which is driven by Byron. The distance which is traveled by Eve is given by this equation. ET is equal to 10t squared. For Byron, the equation is given by BT is equal to 5t squared. The first part of the question asks, plot the graph of ET and BT for different h values. H here is the head start which is given to Byron because Byron's car is moving slower. If h is 1, 2, 3, and 4, we are supposed to plot the graph. So meaning that we have to plot 5 graphs here. 1 for ET and 4 for BT. So let's start with drawing our coordinate system. This is our time and this is the distance. Now I'm going to start plotting the equation of the distance for Eve, which is E is equal to 10t squared. Roughly when t is equal to 0, E is 0, which is here. When t, let's say, is 5, 1, 2, 3, 4, 5 seconds, then 5 squared is 25 times 10 is 250. So if this is 100, 200, 300, 400, 250 is going to be somewhere around here. So this is going to be the point, and our graph looks like this one. Now I'm going to plot the same thing for Byron. If the head start is 1, then I call it B1. And B1 is going to be 5 times t plus 1 squared. So I'm going to assign the same 2 points, and I'm going to say if t is equal to 0, then 0 plus 1 squared is 1 times 5 is 5. So it's going to be somewhere very close to origin. Remember, this is 100, 200, 300, and 400. This is 1, 2, 3, 4, 5. Now if I assign t to be equal to 5, I'm going to get 5 plus 1 is 6. 6 squared is 36. Then 36 times 5 is going to give me 180. So if t t is equal to 5, then you are going to get 180, which is somewhere around here. So our graph now would go something like this one. So this is our B1, and this one is E. Now let's plot roughly B2, which is 5 times t plus 2 squared. Again, when t is equal to 0, you get 0 plus 2 is 2. 2 squared is 4. 4 times 5 is 20. So it's going to be somewhere around here, the start point. And then when t is 5, we are going to have 5 plus 2 is 7. 7 squared is 49. 49 times 5 is 245. So this means that for 5, then it's 245, which is going to be somewhere around here. Somewhere around here, less than 250. So our second graph is going to be something like this. This is B2. The next graph is going to be B3. When head start is 3, so we get 3t plus 3 squared. When t is 0, then you get 3 squared is 9. 9 times 5 is 45. So it's going to be somewhere around here. The distance, the initial distance. When t is equal to 5 again, we get 5 plus 3 squared, which is 8 squared. 64 times 5 is 320. If 300 is here, so 320 is somewhere around here. So this is the point, and our graph is going to be somewhere along here. We call this one B3. And the last one is B4, which is equal to 5 times t plus 4 squared. Now when t again is equal to 0, then you get 0 plus 4, which is 4 squared. 16. 16 times 5 is going to give you 80, which is somewhere around here. And when t is equal to 5, you get 5 plus 4 is 9. Squared is 81 times 5 is 405. So you get somewhere around here. So your graph looks like this one. So these are the 4 graphs, and you can see that the shift is all starting from B1 to B4 is going to be going to the left, which explains plus H. So the shift is always left. Remember, the formula is T minus H. The next part of the problem is if the race is, the end line is 400 meters away, how much head start can Eve give to Byron and still wins the game? If you look at the graphs here, 400 meters is right here. In cases B1 and B2, you can see that Byron finishes 400 meter more than the time that it takes Eve to finish the game. Now B1 is 1 second head start, B2 is 2 seconds head start, and when you go to B3, the head start is 3 seconds. So this means that some time between 2 and 3 seconds, if the head start is 2 to 3 seconds, still Eve is going to win the game. So we can say about 2.5 seconds. So if the head start is not more than 2.5 seconds, still Eve is going to finish the game. Now, if the question is to find the domain and range of these functions, you can see that for instance, for B1, the range has to be, remember, B1 is equal to 5 times t plus h, which is 1, t plus 1 squared, which is this graph. Now, if you look at the graph, you can see that the domain is going to be t has to be in R, and t has to be greater than or equal to -1, and the range is going to be B has to be in R, and B has to be less than or equal to 400, greater than or equal to 0. Again, if you look at this graph, you can see that your time is always greater than or equal to -1 second, okay? And your range is all these values, which is going to be from 0 to 400. Now, if you look at the 2-second head start, we are going to have exactly the same type of domain. Our domain is going to be all real number, but this time the domain, the t value has to be greater than or equal to -2. And the range is going to be the same thing. B has to be in R, and B has to be less than or equal to 400, greater than or equal to 0. And the same for B3 and B4. But the time has to be greater than or equal to -3 and -4. For Eve, the function is 10t squared. So we can see from the graph that the t now, because there is no head start, the domain is t in R, and t has to be greater than or equal to 0. This is for Eve. And the range is E in R now, and E has to be less than or equal to 400, greater than or equal to 0.